Hello and welcome to another part of my Souls-like combat system tutorial series. In this episode I'm gonna show you how to create complete target lock-on system. So firstly, let's create an input action, right click, input action, and let's call it target lock-on. Open it and add one trigger. This one will be tap. And now go to the input mapping context, add one mapping, the target lock-on, and select whatever you want. For me, I'm gonna use Q. Now let's create an actor component that will handle all of the target lock-on system. So create an actor component and name it target lock-on component. Open it and create three variables right here. First one will be lock-on radius. It will be float. Then we will have lock-on class. This will be actor, but it will be class reference. And both of these will be editable and expose on spawn. And now let's create one more variable called target locked on. And this will be just a simple actor. Now we need to get player character reference, so get player character and cast it to the third person character. And because the player character is third person character, we can just convert it to pure cast. And now just promote it to a variable called player reference. Now we can actually start to create target lock-on system itself. So right click, create a custom event. This one will be called trigger target lock-on. And also let's set it up in the third person character. So right click, get your input action, then we need to add the actor component itself, so add target lock-on component, get it, and trigger target lock-on. Now when you select the target lock-on component, you can see on the right side that there is lock-on radius and lock-on class. I'm gonna set the radius to 1650. Lock-on class for me is gonna be, of course, the master enemy. Now, first thing we need to do is create a sphere around the player and check every target that is near the player. So for that, let's create a function. This function will be called trace for targets. It will be pure and it will have one output of the type actor. It will be an array and it will be called targets. So firstly, let's create the sphere around us. So multi-sphere trace for objects. And the start and end will be the player's location. So get player reference and get actor location. Of course, the radius will be lock-on radius. And normally you would just make an array in the object types and you would set it to pawn. But there is a big problem with this and I'm gonna show you what I mean. Let's just first check if we actually hit something and then the out hits. I'm just gonna get length. You don't need to do this. I'm just gonna show you how it actually bugs. And if I'm correct, it also does in Unreal Engine 4, not only 5. Now I'm just gonna untick the pure for now and get this. So you can actually see that when I hit Q, it says 23 on the left side. But there is literally just one enemy here and it doesn't make sense. And it's just because the mesh is actually created from multiple parts and each and every part of the mesh is actually in the trace. For that to actually change, so we won't have insanely costly tracing, we need to go to the project settings, type channel right here and create an object channel just by clicking on this, set the default response to ignore and I named it lock-on pawn. And when you've done this, go to the master enemy and add a collision right here. It doesn't matter what collision, but I'm just gonna use capsule collision and I'm gonna call it lock-on collision. And just this lock-on collision, when you scroll down at the right side, set the collision presets to custom, set everything to ignore, and the object type will be lock-on pawn. And when you do this actually, and go back to the target lock-on component, set this to lock-on pawn, and now when we hit play and click Q, it just gives us one output. I really don't know why this is still a thing, but I guess it's just how it is programmed. And this is the workaround around it. So go back to the target lock-on component. I'm just gonna delete this and set it to pure. Also delete this and let's actually continue. So when we actually hit something, let's for each loop the hits, break the hit result from array element and check if the hit actor is child of the lock-on class. So first we need to get class And then we need to type is child of. Of course, the parent class is lockon class, and the return value will go to the branch. Now, if this is true, we need to set the target to an array. So create a local variable and call it local targets. It will be an actor, and of course, an array. And now just get it and add to it the hit actor. And when the for each loop is completed, we just output the local targets. Now with this, we get all of the targets that are around us, but we need to get just the one closest to the center of the screen. Let's just imagine that there is something in the middle of the screen, and that will check which target is closest to the center, and that is the one that we actually want to select. So for that, let's create another function. This one will be called check for closest target. It will have one input of the type actor, array, and it will be called targets, and one output, actor, single, target to lock on. Also, we need to create two local variables right here. First one will be local compare float. Of course, it will be float. And another one that will be called local target to lock on, and that will be an actor. Now let's for each loop the input targets. And now firstly, we need to check if the target is actually not behind some kind of obstacle or wall. So for that, let's line trace by channel. The start will be the world location from the player's camera. So get player reference, get follow camera, and get world location. And the end will be get actor location from the array element for each loop. Now don't forget the trace channel is visibility. So if your enemy doesn't have the visibility right here to block, it will not work. So set it to block. Now let's check if we hit something, and if we did, we need to check how close the target is to the center. So for that, create a function called check how close target is to center. This one will be pure, and it will have one input of the type actor called target, and one output of the type float called return value. Now to actually check something, how close it is to the center of the screen, you do it with this kind of math. So from the target, let's get actor location, also get the player reference and get actor location from him, find look add rotation, and the return value get rotation x vector. Now again, from the player reference, we also need to get the follow camera because we are checking it from the camera, not from the player, and get forward vector of the camera. And now we just need to dot product these two numbers. And the closer the number or the return value is to 1, the closer it is to the center of the screen. So now get back to the check for closest target, get the function that we created. The target will be array element from for each loop. And with this, we can just compare float. The input will be the return value from the function, and output will be local compare float, which is 0. And if input is bigger than local compare float, first thing we need to do is set the local compare float to the return value from here, and then set the local target to lock on to the array element from for each loop. And when the for each loop is completed, we actually get the target that is closest to the center of the screen. So let's just output the local target to lock on. Now, when we go to the event graph and grab the check for closest target, oh, I actually forgot, it should be pure. Now drag this to that. And firstly, check if this is actually valid, because if it's not, then it means that nothing targetable is around the player. But if it is, let's just set the target lock on to target to lock on. And now we can actually set the target lock on system because we have the targets to lock on. So you can do it with event tick or set timer by event. It doesn't matter. I'm gonna use set timer by event. The time can be delta seconds. It will be looping, and the event, let's just create a custom event, and this one will be target lock on. And if we don't want to lock on anymore, let's just create a custom event called stop target lock on, and it will just clear and invalidate the timer handle itself. Now for the target lock on, first thing we need to check is if the target is actually still in the lock on radius. So get the target lock on and get player reference, get their actor location, and check the distance. And we are checking if this is greater than lock-on radius. And if it is, we want to stop the target lock-on itself. Now, if it isn't, we need to update the camera itself so it will always face the target we are locked on. So first, get the player character and get controller. From this, set control rotation, and let's split this struct pin here because we will change some numbers here. So firstly, get control rotation and break rotator, and the X value will be the same. So let's just drag it here. But the Y and Z will be kind of different. So for that, let's actually create another function. This one will be called get lock on camera rotation. And here we are actually going to set the math to rotate the camera itself. So for that, let's get the player reference, get follow camera, and get its world location, then find look at rotation. And this return value will be the return value that will be outputted in the return node. So let's create a return node and just drag this here to create a pin. Now we have the start, but for the target, we actually need to get the target locked on and get actor location. Now split the struct pin and also make vector. The X and Y will be the same, but the Z number will be different. So for that, let's get again the player reference and get the target locked on. Again, get their actor locations, distance, and this will be divided by 2. And then the return value Z will be subtracted by the divided number right here. And let's just plug everything in. So what this actually does is the camera will be always panned in a way that player can see his character and also the enemy character at all times. Because when you don't see the enemy character, the combat system itself is kinda iffy, let's just face it. And this number right here sets how much the camera will be panned, which means how much this will be happening. I found out the value 2 is good, but you can change it however you want. I'm just saying it so you actually know that it is here and it is changeable. Now go back to the event graph, get the get lock on camera rotation, and let's just reinterp 2. The current will be get control rotation and target will be the get lock on camera rotation. Now the delta time can be 0.01, interp speed can be 1, and the return value will be split, and the Y will go to the control rotation and Z also. And now when we play and hit Q, it is really slow. So let's set the interp speed to, for example, 10. Yes, now it locks on properly and you can see that the enemy is always visible on the screen. As I said, you can change the number right here, and I'm gonna show you what it actually does. When I divide it only by 2, you can see the camera is panned in a different way. And when it's gonna be, for example, 10, you see that the player blocks the enemy. So as I said, 2 is the best for me, but you can change it however you want. So now we can actually lock on to the enemy, and when we copy the enemy multiple times right here, I'm gonna show you that when I look on him, it locks right there. When I look on this character, it locks on that character, and when I look at the middle character, it locks on the middle character. But we still cannot switch between the characters themselves. So let's change that. In the Souls-like games, when you have target lock-on already and you move your mouse to the left, it will target another character on the left, and the same goes for the right. I actually don't know how to do that. If you know, let me know in the comments, and I'm gonna pin your comments so everybody else can have that knowledge. But I'm gonna use mouse wheel up and mouse wheel down for now. So right click, mouse wheel down and mouse wheel up, but we still cannot assign anything to them. So go back to the target lock-on component. Let's actually create 2 custom events here. First one will be switch target on left, and the other one will be switch target on right. So firstly, what we want to check is if we are actually locked on. So get the target locked on and check if it is valid. And if it's not, we don't want to do anything. But if it is, we actually want to switch the character. So Let's create a function right here. Let's call it getTargetOnLeft. It will have one output of the type actor called leftTarget. And this one will be really similar to what we did before. So get trace for targets, for each loop them. And from that, we want to line trace for objects. Again, the start will be the camera world location. So get player character, get follow camera, and get world location. The end will be again from array element get actor location. And the object types, let's just make an array, and it will be lockOnPawn. Now, firstly, let's check if we actually hit something. And if we did, let's break the hit result. And actually, firstly, let's check if the target is not the target we are currently locked on. So get the target locked on and also type not equal, and it shouldn't be equal to the array element. Now we can get branch and also end boolean. And the other one will be the check that will actually check if the character is on the left side of the screen. So for that, let's get the player reference and let's just copy the follow camera right here, get right vector. We need to dot product this, and we will dot product it with the normal from the hit result. And then we just need to asyn degrees and check if it is greater than 0. And that's all you need to do to check if the character is actually on the left side of the screen. Now the last thing, let's just create again the local variables called target compare float, target to lock on, and again check how close the target is to the center. The target is of course the array element, and we need to compare the float with this as an input value and local target compare float as compare with. And if it's again greater, set the local target compare float to the return value from here. And again, local target to lock on will be the array element from for each loop. And when the for each loop is completed, we just want to output the local target to lock on. Now the same thing will be for the right side. So let's just right click on the function and duplicate it. And let's call it getTargetOnRight. And the only difference in this is that this right here is not gonna check if it's greater than 0, but it will check if it's less than 0. And with this, you get the targets on the right side of the screen. Now go back to the event graph and get the target on left and also on right and set it to the target locked on. Now when we go back to the third person character, we can just copy the target lock on component and switch target on left and also switch target on right. Now when we play and actually lock on someone and use mouse wheel, it will go to the left and then it will go to the right. And we actually get one error here, so let's check it. Actually, I know what it is. It is when we get target on left, but there is no target on left, it still sets the target lock on. So let's just check if this is valid. And with this, there shouldn't be any bugs. So let's just copy the enemy multiple times. And now when we play and actually hit Q and use mouse wheel, you can see that everything is working as it should. You might experience sometimes a bug, but this is the best way how I was able to make the lock-on system with switching. So yeah, now we can actually set the movement of the character to correspond how it would be with the Souls-like games. So for that, we need to actually create a blend space. So right click, animation, and create blend space right here. Let's select your mannequin, and I'm gonna call it BS player lock on. And there are multiple ways how to set up the 3D blend space. I'm not the best at it, but I'm gonna try my best to show you how I am doing it. So firstly, the horizontal axis will be the movement direction, and it will go from -180 to 180. Let's set the grid divisions to 8. Vertical axis will be movement speed, and for me it will go from 0 to 400. Also check the snap to grid. And now let's start. So firstly, we need an idle. I'm gonna also set it on the corners right here. Then we need walk animations. Oh, and also set the grid divisions here also to 8 for me. So I can actually go and set this to 150 movement speed. Now the right side will be the right side of the animations and left side will be the left side of the animations. So right here, let's just get the walk front 45 to the right. Then we want to strafe to the right, then walk back right 45, and also at the end, we want to walk back. The same thing goes for the left side, so front left, left, back left, and back, because this is 100 degrees, so this means it is walking backwards. This is literally just degrees, and I just set it up to 8 divisions, so it goes to 45 each one. Now up here will be the running animations, so let's just type run, and firstly here will be run front, then at the corners will be run back, run right will be at the middle, run left at the middle right here, and then front right, back right, front left, and back left. And now when you hold Control, you can actually see how it will look. But for it to actually be used, we need to go to the animation blueprint, set up the direction right here, and you calculate direction pretty easily. Just drag from the character reference, get actor rotation, and from velocity, calculate direction. The base rotation will be actor rotation, and this will be promoted to a variable called direction. Now, for us to actually check which one of the blend spaces we should use, we need a variable of the type boolean in the target lock-on component that I forgot about. This one will be called lock-on. And let's set it to true before we start the timer by event. And also set it to false at the stop target lock-on. Now, when we go back to the animation blueprint and get target lock-on component, we can actually get lock-on variable and check if this is true. For that, let's just create another variable right here called the same and hook it right here. Now we can go to the locomotion and drag from the idle movement, add state. This state will be called lock-on movement, and it will go to that state only when lock-on is true. And also it will go back only if lock-on is not true. Now in the lock-on movement, we need to set the blend space. Type the BS player lock-on and get player blend space. The movement direction will of course be the direction, speed will be speed. Now when we hit play, you can see that the player is still not moving correctly. And that's because his orient rotation movement is set up differently. Oh, there is an error right here, so let's actually check it. I think it's too fast, so let's just add one delay here. Duration will be literally 0, so yes. It's just too fast it's just fastly updating, so that's why it doesn't work. So let's just add one delay here and you should be okay. Now, the movement. To change that, we need to go to the target lock-on component and change the movement system itself. So get the player reference, get character movement, and drag from this, set orient rotation to movement. This one will be false. And also we need to use controller desired rotation. And also when we stop the target lock-on, we need to do this, but change it. The use controller desired rotation will be false and orient rotation to movement will be true. And with this, you can actually move just like in a Souls game. Oh, and we can still move camera, which we shouldn't be able to. So I do apologize for that. I forgot to set ignore the look input. So for that, let's get player controller and set ignore look input. And this will be true. Also set it before the timer event itself. And copy the player controller right here at the stop target lock on and reset ignore look input. So we actually will be able to use mouse when we stop. So now we cannot even use mouse, and when we go away, it actually turned off the lock on. And I also forget to stop the lock on itself. I do apologize again for that, so that's pretty easy. So let's just get the target lock on component and get lock on, check if that is true. If it isn't, we want to trigger the target lock on, and if it is, we want to stop the target lock on. Now we can actually stop the target lock on anytime we want. So thanks for watching. I hope this tutorial helped you somehow, and have a wonderful day.